Welcome back. It's time for video 2 from Unit 5. We're going to build on the skills that we learned last video, where we basically looked at the notion of graphing a linear inequality, paying attention to solids and dotteds and shadings and aboves. And we're going to work our way towards systems of inequalities, wherein the goal becomes to find what part of the grid is common to all shadings, the overlap, if you will, the intersection, if you like a good math word. So we're going to branch it out. We're going to build some systems, and we'll look at graphings of those systems. Here comes the beginning of the PowerPoint for video 2. Let's rock and roll. Lovely slide, Dale. Okay, so last time we just did individuals. So now you're going to have at least 2. All right, so a system of inequalities. We'll have 2 or more inequalities, wherein you and I will take one graph grid, and on that same grid, we'll graph each of the inequalities and determine a shading relative to each inequality. Then we'll turn our attention to finding out what portion of the grid contains the overlaps in the shades or the intersections on the shades. And that intersection is the system. Those points that live in that shade, in that multiple shaded section, are the solutions to the system of the inequality. If you find it easy to use colors as you do these, feel free to do that. Bust out your colored pencils, or shoot, go old school and break out your Crayolas for all I care. But whatever helps keep your vision straight as you do these, I'm perfectly on board with. All right, here we go. Here's our first example. Luckily for us, both inequalities have y isolated, so we can draw some inferences right away. Not going to be particularly difficult to graph either of these. The first one looks like it should be a solid line. And since the equals is an option for us, we'll be shading below because it's a less than or equal to. Second inequality is also a less than, so we'll be shading below. That one will be a dotted line as we get ready to go. So here we go. Now I'm honestly, I probably didn't do us any favors on the scale that I picked, because instead of every slash being 1 unit, every slash on that grid is 2 units. So what should be an intercept of 6 on the y-axis. Be careful. It looks like it might only be 3 up, but remember, each of those slashes is 2 units, so that really is 6. Their slope's -1, so we'll go down 1, right 1, or down 2, right 2, or you guessed it, if we want, down 6, right 6, and we can get to a second dot. As previously informed, that's a solid line, and because of the less than or equal to, shading relative to that line is below. So if that's all we had, the solution to that inequality is the green region shaded. Okay? Second of the inequalities on that system was this one. So the intercept's at -4, so you'll notice again, it's the same scale at least. Every slash is worth 2 units, as opposed to what maybe we usually do with 1 unit. So your intercept's at -4, your slope's at 2. So first dot on the y-axis at -4, up 2, right 1, or up 4, right 2, get you a second dot. This time your graph is a dotted line because there was no equals option. Again, since its y is less than, the shading relative to this line is below as well. So you get the red shaded as the dots that satisfy this inequality. So if you put both inequalities together on the same grid, and I kind of wish I had just done this initially, what you get is what's on your screen now. And the portion of the grid that picks up both shadings is brown. Lovely color choices here, very bold and decisive. So the solution to this inequality, represented as you see the graph, would be the brown region. The things that are green out there on the extreme left edge don't solve the inequality. They solve one, but they don't solve the system. They solve the first inequality only. And that's it. So solving systems of inequalities constitute you and I drawing some graphs whereby each graph will have more than one inequality on it. If you get bogged down by having a lot of clutter and a lot of shading going on, I'll show you a method wherein you just kind of focus on the end result, what portion of the grid picks up all shadings. So if you like this, it's an option for you. You can run with it. Here's another example. The first one also has y isolated. Going to have an intercept at -1 and a slope of 2/3. Second inequality also has y isolated. Going to have a slope at -1 and an intercept at 2. Both of these are going to be solid lines. So the first dude, I'm going to go in blue. So you're going to see the first dot at -1 for your y-intercept. From that, we'll go up 2 and we'll go right 3. Second guy I'm going to use is a red line. Now I'm just marking these as solids in case I get forgetful. All right, so let's go ahead and go do some graphing. First line coming in with a y-intercept at -1. From that dot, if you go up 2 and right 3, you will get to an ordered pair that is 3, 1. And you can kind of see that as falling on the line. Solid line. All right, time for shading. It was y is greater than or equal to, so we should be shading above that line. So if you don't want to do all the coloring, you can just denote with some arrows which way the shading goes relative to that line. All right, same grid. Let's get the red guy in play. He's got an intercept of 2 and a slope at -1. So your first dot would be on the y-axis at 2. From there, down 1, right 1, down 2, right 2. Get you a second dot, get the line drawn. Again, solid. Again, it's y is less than or equal to, shows shading relative to the red line. Should also be below. Well, that's pretty cool. So now what you seek is the portion of the grid that covers both forms of shading. So in effect, above the blue line and below the red line. Let's see how I did. Ha! Amazing. All right, so the orange represents the solution to the system, and you could have done that without all of the other extraneous shading if you didn't need to do it. All right, so that's example 5. What do you got going on in this one, Dal? Well, I don't have y isolated, so we'd have some work to do. On the first guy, we'd have to subtract 2x, and we'd have to subtract 3. I decided we should show that in blue, and it would be dotted. So that would be the guy we're going to graph. So your first dot's on the y-axis at -3. From there, we would go down 2 and right 1. All right, so, or if you really want to freak people out, we could go up 2 and left 1. But actually, you can kind of see that arrow head seems like it might be falling on the ordered pair 1, 5. Lines in play, it's a greater than. We should be shading above the line. So the arrows indicate the direction of shading relative to the first line. Second guy, again, you want to probably get y by itself. So you'd add x, and you divide by 3. Your y-intercept's at 3, slope's a third. So your first dot's on the y-axis at 3. From there, you'll go up 1 and right 3. That locates your second line. In this case, I said red. Notice again, it's dotted. That's y is less than. So referencing that line, the shading should be below. So to the bottom, if you will. And then what are you going to find, Dale? We're going to find things that are above the blue line and concurrently below the red line. And again, a lovely orange shade by yours truly. So the guys that are in the orange shaded area solve the system of those two inequalities. Not hard, not difficult. Shortcut if you don't want to do all the shading, because you really just need to know where the intersection of those shaded spots fall. All right. Now, this is going to set the bridge for us to move across to the notion of linear programming. This is a more complex system, but 3 of the inequalities aren't very complex. Inequalities that simply involve x are going to be vertical bounds. Inequalities that simply involve y are going to be horizontal bounds. The bottom guy is going to be something that will transform, okay? So if we get ready to look at the first inequality, since they're x-onlys, those are going to be vertical lines. The first one will be 2 units to the right at +2. The second one would be 10 units to the right at +10. The third inequality would be 3 units horizontal. So up 3, if you will, at y = 3. All right, that last inequality, if you want to go ahead and isolate, you certainly could solve for y. That doesn't look so nice, you know? That doesn't look so nice. So you know what you might want to do? You might want to not do intercepts and slopes to get that line in play. You might want to do a little plug and chug, maybe make a T-chart, you know? So if you say, well, I'm not graphing 23 halves or 46 fourths, I'm kind of with you, right? That's not so swell. So maybe a good choice for X plugged in would get to something for a nice choice for Y. There are your first 3 guys. The blue line is X is equal to 2. The pink line is x is equal to 10, and the brown line is y is equal to 3. So relative to those guys, we would be to the right of 2, to the left of 10, and above 3. So we could do the arrows trick that we saw previously. If you want to put that last guy in play, I suggest we do a T-chart. So with a little plug and chug action, I said, let's pick 2 for x. And if we plug the 2 in and do some arithmetic, y comes out 10. If you really want an insider secret, I'm using the 2 that you saw previously at x is greater than or equal to 2 because I cheated. And don't be surprised if I pick 10 for the next choice. You almost like knew it was going to happen. All right, put 10 in and do some arithmetic, and you're going to get 4. That gets us everything we need to graph that last inequality. All right, so an ordered pair at 210 and a second ordered pair at 10-4, solid line, and we'll be graphing so that the shading is below that line. All right, so there is that last line in red, right, for the T-chart we just built. And here come the shadings. We're going to go to the right of x is greater than, so numbers that are greater than 2. We're going to go to the left on x is less than 10 to find numbers that are less than 10. We'll go above on the brown line for y values that are greater than 3. And then last but not least, for the guy we just did, since it turned out to be a less than, we were looking at values below the red line. What we would need to determine is the section of that grid that picks up all of those shadings. And if Del was successful in his endeavors, it looks like this. Wow. So a little more to do because you got more than 2 inequalities, but as long as you get that vertical and horizontal aspect, it wasn't too painful. So that's where it's all going to go. Next video processes the notion of linear programming, but to do it successfully, you need to be able to graph systems of inequalities, which was your focal point for video 2. Be back soon with video 3. See you then.